In this part, we are going to write transform equations with the given graphs. So in our first example, we have a graph of absolute value. So let's write out the parent function. So I'm going to write parent function here. Which is f of x equal the absolute value of x. Now, let's see the transformation. So, if we compare it with the parent function, which is right here, so if we take a look at that one, we notice that it's flipped or reflected over the x-axis because it's facing the opposite direction. So, let's say that it's reflected over x-axis. Now, it wasn't just that. The original parent function, it goes through the origin. This one does not. We notice that it moved from the origin to the right 1 unit. So, 1 unit right. So, there were two transformations, reflected over the x-axis and 1 unit to the right. So now we're just going to write our transform equation. So we're going to use g of x. Now we can write the one that translated or shifted left, right, up, down. So since this one moved to the right, it's going to be inside the function. So x minus 1. Now since this reflected over the x-axis, that means that the negative has to be on the function or outside. So we're going to draw our absolute value lines, and the negative will be outside. So we have a negative saying that it reflected over the x-axis, and then we have minus 1 saying that it moved, shifted, or translated to the right. So our transform equation is g of x equal negative of absolute value of x minus 1. So for our second example, we have a quadratic graph. So here's the graph of the parent function, facing upwards, going through the origin. This one is facing the opposite direction and it's not going through the origin. So first step is we're going to write the parent function. So our parent function is f of x equal x squared. And again, the reason we're writing the parent function is so that when we get our transform equation, we can compare it to see if it's alike. Now let's describe the transformation. So before, I said that it's facing upwards. This one is facing downwards. So that means that it reflected over the x-axis. So our first transformation is reflected over the x-axis. Now comparing it again, the parent function is going through the origin. This is not. We notice that it shifted 1, 2, 3 units to the left. So it moved or translated 3 units to the left. So 3 units to the left. Now we got our transformation. Nothing else happened. So we're going to use these two information to make our transform equation. So g of x, now the reason again we're using a different notation is we can't say f of x. If we use f of x, then it's supposed to equal x squared. But with the information of the transformation, these two right here, it has to be a different function. That's why we're using a different notation. So let's take a look at the one that moved to the left. That information means it was inside within the function. So we're going to have to write x plus 3. So since it was within the function or inside, it's going to be in the parenthesis with the square outside. Now we have to put in the information for reflected over x-axis. For that means the negative is on the function or outside the function. So right here. So negative on a function means reflected over the x-axis plus 3 units to the left. So our transform equation is g of x equal negative of x plus 3, or the square of x plus 3. Here is our third example. So this graph is a square root function. So I'm going to write the parent function f of x equal the square root of x. And let's compare it to the parent function. Now this one is starting at the origin and is going towards the upper side. Over here it's not at the origin, so it didn't start at the origin, it started here and it's going downwards. So one transformation is that it reflected over the x-axis, and the other one is that it shifted to the right. So let's write out the information. We notice that it shifted, no, not shifted, reflected over the x-axis. So reflected over x-axis. Now the parent function started at the origin, but over here it did not. It moved 3 units to the right. So 1, 2, 3. So 3 units to the right. Now the reason we write out the transformation when we're trying to find and write out the equation is that since you have the information, it shows that I know what I'm doing. So in terms of a test, if I want to get partial credit, and if I write out the transformation and it's correct, I can get partial credit. In the event, maybe my final answer wasn't fully correct. Now let's write out the information for square root. So g of x equal, now we're always going to focus on the one that moved to the left or to the right first. So since it moved, translated 3 units to the right, so on the inside it's going to be x minus 3. So minus 3 means 3 to the right. Now it's going to be inside the square root, and since it reflected over the x-axis, that means that the negative is on the function or outside the function, meaning outside the square root. So we have g of x equal negative square root of x minus 3. Here is our fourth and last example. This is a graph of a cubic function. So our parent function is f of x equal x to the third power. So if we compare it with the parent function right here, we can see that it reflected over the y-axis. So here it's going upwards, it's going upward on the right side, but now it's going upwards on the left side. So it flipped, reflected over the y-axis. And also the parent function went through the origin. This one did not. So that means that there's another transformation. So our first transformation is, since it reflected over the y-axis, so I'm going to write that down. Alright, so reflected over the y-axis. Our second transformation, since it didn't go to origin, but here, that's the center. So let's check. 1, 2, 3, down. So it shifted 3 units down. So I'm going to write 3 down. Now we're going to write our transform equation. So g of x. Since this one is down, and the last 3 example was moving left or right, we're not going to focus on that one first. We're actually going to focus on this one. So, since it reflected over the y-axis, that means that the negative was inside the function, meaning on x. So, negative on the x, so inside the parentheses with the third power. Now keep in mind, even though it doesn't have parentheses, we could write it and it would be just on the x. So negative on the x means that it reflected over the y-axis, and since this one is 3 down, that means minus 3 outside the function. So negative on the x reflected over the y-axis, and then minus 3 units down. So our transform equation or function is g of x equal the cube of negative x minus 3.